Hi, uh, welcome to the first class of electricity and magnetism. This is the very basics of science. In science, it is basically a branch of science which deals with the laws of nature, the laws of electricity, and how it is formed. Right, so we will be discussing the basics of electricity and magnetism, as in how electric current is formed. You might have heard of this word current, electric shock. You might have experienced that somebody, maybe your parents or your elders, say, "Don't go, don't put your finger into the socket. You might get electric shock." So, what exactly is electric shock? What are the factors that are responsible for electric shock and electricity? Now, whenever we hear someone, we uh, we don't have electricity in our house. What does that means? What does the word electricity represents? So we'll be starting with the very basic introduction, as in what is electricity and what is magnetism. I want you all to, gather some questions here, some remarks in your mind, as in you all have heard the word electricity. Now, in the same manner, you might have heard the word magnetism. In the very childhood, you might have played with two magnets. You might see the magnets attract each other or repel each other. If the two magnets are sticking towards each other, that is attraction, and if you try to pull one magnet with the other, that is repulsion. So what exactly is this magnetism, and what are magnets? How are these magnets forms? So we'll be learning each and everything in very basic manner, yet in a very detailed manner, so that you'll be having a clear understanding of these two basic words that we use almost every day in our life. Okay, so before starting, I just want to give you a quick fix. Electricity is responsible to produce magnetism. Okay, and magnetism can also create electricity. Now you might be wondering, if the electricity can produce magnetism, right? Why do magnets don't have current? When we touch the magnets, why don't we feel the current? In the same manner, if magnets can produce electricity, where it is used? You might have used speakers at your homes, right? Any device which is responsible to create an audio output has magnets. Now 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 I think you might be able to relate the things. That magnet is producing electricity, and electricity in which form? Sound waves form. Similarly, when we plug on the speaker or the audio device to our household sockets, we are supplying electricity or electric current, and that magnet is producing what? Sound. So these two terms are very similar to each other. Now, I know you might be having many questions, many doubts, and you all are very curious to know about these two terms. So we'll be discussing everything in detail. Let us start with the very first basic of current, like what is electricity, right? We all know, we all say in our lives that uh, today we don't have electricity in our homes, we should turn on the inverter. Yes or no? So electricity is nothing but the interaction of electric charges. Now, what are electric charges? Now, you might have learned or you might have heard the terms protons and electrons. Where they are formed, where they are existed? In the atom. Atom consists of protons as well as electrons, and every atom consists of positive as well as negative charges. So these two positive and negative charges, also known as protons and electrons, are the two different type of electric charges. Got it? So whenever the electric charges means some particles of positive charges known as protons, some of negative known as electrons, when they all interact with each other, the electricity is created. Now if you touch a wire, you don't feel any shock, right? Wire is made up of copper or aluminium or gold. Gold is expensive, super duper expensive, hence we don't use gold as wires in our household things. Majority you will see the wires or any anything that is related to electricity or electric current is made up of either of copper or aluminium. Gold is the best conductor of electricity, then comes the copper, and lastly comes the aluminium. Okay, so wherever we have to save some money, do the cost cutting, we basically supply wires or transformers made up of aluminium. Now whenever you touch the wire, you don't feel any electricity until and unless it is plugged on into a power source. Now that copper wire consists electrons as well as protons. They all are in a very scrambled state. Scrambled state means that they are not interacting with each other. The two, they have some space between the electrons and the protons. Now when you plug on that wire to the socket and you turn it on, what happens? The electricity coming from your household socket or your household electric connection will send what? Protons and neutrons. Then there will be a interaction of particles, charged particles. The you might have you might know that the opposites attract each other. Similarly, protons carry positive charge and electrons carry negative charge. They attract each other and they fill in all the voids or the blank spaces inside the wire. Okay, when the blank spaces and voids are filled up, what happens? Interaction will happen, and ultimately you will receive a electric shock. Very easy, very clear. The same thing I have represented with this diagram. You see, whenever you plug this particular switch on, the interactions between this wire goes on. Interactions will what do? They will fill up the blank spaces and voids, and hence you will receive a electric shock. That is why it is advised, do not touch the wire with your bare hands. Always wear rubber gloves. Why? Because rubber is a poor conductor of electricity. Okay. Now, so as we know that in this universe there is a law. Everything goes by law. You might have also learned in class 8th or class 9th the laws of nature, right? The first law of motion, the second law of motion, the third law of motion. Similarly, our electric charges, protons and neutrons, also possess some sort of law. What law? Same as we discussed before, that like charges repel each other and unlike charges attract each other. These are the only two laws. Okay. Like charges, what will do? They will repel each other. If you uh, if you take two protons carrying both positive charges and you tend to get them close enough to each other, they won't be filling any void spaces or any blank spaces. Instead, what will they will repel each other, creating more and more voids. But if you place two unlike charges, they will fill up the void spaces, and they will attract. If they attract, interaction will happen and electricity will be formed. Okay, now to explain these sort of laws, the unlike and the like laws, we have numerous uh, physicists, numerous scientists who have given their own respective theories. One of the most eminent physicists in the field of electricity and magnetism is Coulomb. Okay, he gave his laws. What did he say? I'll just explain you the statement what he said, and then we'll discuss on the terms and conditions that are used into the statement. Coulomb law states that the size of charges and the distance between them are very important factors in calculating the strength of electric force between charged particles. Now, don't get confused. It is not as difficult as it sounds. What does he mean to say? That the sizes of the charges means the sizes of protons and the neutrons, and their difference between them, like how in how many distance they are placed, whether they are at 1 centimeter apart or 10 centimeter apart. These two factors only. What two factors? First factor is the size of charges. Second factor is what? The distance between them. Only these two factors are responsible to find out or to determine what? That how strong is the electricity, how strong is the electric force. Now, what does that mean? How strong is the electric force? Okay, leave everything behind. We might use these terms in our day-to-day life, that today the weather is very bad and the voltage is very low. The AC is fluctuating. Oh my god, the current is very low today. Turn off the refrigerators, turn off the TV and the air conditioners and other household equipments. Why do we say that? That means that the electric force that is coming to your households, to your homes, to your offices, to your schools are very low. The electric force is weak. And why it is weak? It is weak only and only because of these two factors that are mentioned by our dear Coulomb. What did Coulomb said? That the sizes of charges and the distance between them are responsible to find out, to calculate, to understand, to determine how strength or how strong the electric force is. Now you might be considering that if the particle size is very large and the distance between them is very low, whether the electric force will be more or less. Or if the sizes are like very small and distance is like very large, then the electric force is weaker or stronger. So we'll be discussing all these conditions in coming slides and coming chapters. First of all, you just only need to understand these terminologies that we use almost every day in our day-to-day life. I'll take my example. Around half an hour ago, before starting this video, I said to my family that the electricity is weak today. Why I said so? Because the bulb or the light in my room was like very dim. So why it is dim? Only because of two factors. What two factors? That are said by our famous Coulomb. I'll repeat again. One factor is the size of the charges. What charges? The protons and the electrons. Second factor is the distance, how much distance is between the charges. Okay, I think you might be able to correlate these two basic things. Now, to understand that what governs the weakness and the strongness of this charges, for that we'll have to understand two basic terms: static as well as dynamic. What is static? Static is something which is at rest. If we say that boy is static since an hour, that means the boy is stationary or at rest for 1 hour. On the same side, I say Ram is very dynamic. What does that mean? That means that Ram is doing something. It's not like he's running or he's walking or he's doing some sort of physical activity. He might be sitting in a chair or doing some work, writing his homework, giving his tests or studying, but he is doing something. His body is engaged in some work. Hence, Ram is dynamic. And the other person who is absolutely doing nothing is static. Now, static electricity basically builds up of electric charges on an object. I'll take example. When you rub a balloon against your hair, what happens? Just imagine, I'll just give you a minute or so. You might have also done this sort of experiment when you rub a scale on your head and you try to lift the pieces of paper, and they tend to stick on your scale, right or not? Similarly, I'll explain one more experiment. When you rub the balloon, full balloon, inflated balloon, against your hair, the electrons from the atoms, now balloon is made up of atoms, right or not? The electrons from the atoms that make up your balloon and your balloon and hair collide with each other. There is an interaction between your hair particles and the balloon particles. Okay, then what happens? The balloon becomes negatively charged due to electron gain, because your hairs are supplying electrons to the balloon. Now, if you hold that rubbed balloon several centimeters away from your head, balloon automatically attracts to your hairs. It will not fall down, right or not? This is the example how opposite charges attract. Let us again understand that very simple experiment of scale and pieces of paper. Scale and your hair. You rub the scale on your hairs. What happens? Electrons from your hair gets transferred to the scale. Scale becomes negatively charged. When you try to lift that negatively charged scale to a small bits of pieces of paper, the paper automatically attracts. Why? Paper have positive charge, and the scale, which is positively charged at very first glance, you rubbed against your head, it becomes negatively charged. So opposites attracts. Got it or not? Now, after some time, if you leave that scale for like minute or so, or if you leave that balloon for a minute or so, the balloon will fall from your hair, and the pieces of paper that was attracted to the scale will eventually fall down. What is that? It happens or not? I'll just give another 10 to 15 seconds to imagine it happens or not. I want to try, if you have a scale with you, Just try. Rub scale on your head, lift a piece of paper and just keep it aside for a minute or so. The particles will fall down. Why they are falling down? They are falling down because of electric discharge. If something is charged, it will get discharged. When electricity goes from your home, the inverter at your places gets on. And suppose, for example, if electricity does not come for 2 days, we say the inverter is discharged. Whatever the charge inverter has gained from your own household, it will lose everything. In the same manner, electric discharge happens when the electrons move out of the body. We'll take another example. Have you ever received a shock? Small shock when you touch a metal handle or a metal door handle after shoving your feet on the carpet or on the woolens. It usually happens in like winter season when you are wearing woolen clothes. You have like carpeted clothings. You suddenly get up from your bed or your chair, you touch the handle of a door and you receive a very minute sort of shock. What is that? That's electric discharge on a very small scale. So I just want you to do some sort of activity at your places. Can you think of an example of an electric discharge on a larger scale? Think. You can take your time, you can take a day or so, but I want everyone who is listening this video, who is listening to me, should think of an example of electric discharge on a larger scale. I'll give you an example. Magnet. Okay, I think that should be all with this video. I hope every one of you liked this video, and we'll be continuing these small lectures on the basic topics in near future also. Thank you so much for listening.